Our first two speakers today are mission support staff members from the AMADEE-20 Mars simulation. We have Dr. Simone Paternostro from Israel. He'll be speaking first, followed by Willibald Stumptner from Austria. Simone, take it away.
Hello, good morning, everybody, or good afternoon, good evening. Here is about 7 o'clock in the evening after one of the days of our mission here in Israel. So thanks for the presentation, James. My name is Simone Paternostro. In my daily life, I'm a space engineer, but in my free time, I support the Austrian Space Forum as a volunteer for their own projects and missions. But we will see a little bit more about the organization and what we are doing in the next slide. So first of all, the Austrian Space Forum is an organization mainly based on volunteers. It was founded in 1998. It involves more than 200 members that are international professionals and students in the space field, but not only from there, from multiple fields that can be STEM, psychological, business, and so on. And we focus on different area of expertise, in particular the development of projects, and also in terms of hardware, physical hardware. We have developed the two AUDA spacesuit simulator that we will see later on in another slide, but also in Mars analog rovers. So one of the main objectives of this organization is to perform research, so to broaden the knowledge of the international community related to the space field, in particular human exploration, and every consequences or side effects or any other aspects related, like planetary surface operations or even the optimization of remote site support. And in this research, we established a lot of collaboration with other international partners to study human exploration in the different aspects. And one example is the mission that we are now performing in these weeks in Israel called AMADEE-20. But not only the research that is one of the main topics of the organization is also spread the knowledge. So we are involved in a lot of educational and promotional activities, as you can see from the picture, with school and kids to promote the studies of STEM studies and to make people aware of what space is and what can bring to humanity. So as I mentioned, now we are in the Negev Desert in Israel. So the mission started on the 4th of October and will last until the end of October. And then the mission is in collaboration with the Israel Space Agency and is hosted by the DMARS, that they are the organization that developed the station that we will see in the next slide. So the mission itself is a 3 weeks mission isolation, in which 6 analog astronauts will stay isolated in the station, performing different type of experiments. As I mentioned before, the habitat has been built by the DMARS team. They actually recently extended the station from first module that they have until a few weeks ago, and now have two modules. And compared to our previous mission, usually our mission was formed by the analog astronauts and a support team, helping them in the setup of the station, performing the experiment, and a lot of other tasks. But in this case, the on-site support team instead has no direct contact with the analog astronauts, so they are, let's say, isolated from the contact point of view. And beside that, we have also a mission support center that is located in Austria, where there is another set of teams, actually quite bigger than the one we have in Israel, that support the whole teams here from remote. So they are kind of sort of Houston of the Austrian Space Forum. The mission itself has more than 20 experiments from different fields, from geology, psychological, microbiology, robotics, teleoperation as well. And all of this had involved more than 200 researchers from different countries. So like you can see more than 25 different countries. So here you can see just a few pictures coming from these days from the mission. There we have our analog astronauts inside the station, preparing for the EVA with our AUDA spacesuit simulator. And on the right side of the slide, you can see our first full female crew going in EVA. And yeah, this is just a glimpse of what's going on, but you can find a lot of pictures and stories in the official media channels of the Austrian Space Forum. So this is the AUDA spacesuit simulator. Is almost kind of unique. We are one of the few organizations worldwide that can that develop and operate this kind of technology. It's the suit itself, it weighs around 50 kilos. It's unpressurized. The upper part is a hard upper torso. It has a portable life support system with a custom built OBDH defined and developed by the organization itself, and also an advanced human-machine interface. So the suit itself is designed to try to emulate the limitation, the sensorial limitation that a spacesuit would give to the astronauts. So from the limited vision to the also to the tactile sensation. So the astronauts, they wear 3 different layers of gloves, and that this is really limiting the capabilities of handling tools and performing experiments. And so that's one of the objectives of the mission, is to try to figure out if the experiment or how they are designed, they can be compatible for the way they can be operated by the astronauts. And beside that, there is also the astronauts. They're also wearing an internal exoskeleton that limits the movement, so the main joints like elbow, knees, and a little bit also the hands. So you can imagine that staying on EVA for between 4 and 8 hours, but EVA, but in any case, wearing the suits for between 4 to 8 hours per day is quite exhausting, considering the weight and the whole limitation that the suits is imposing on the person. It's very challenging thing, but it's also very interesting and very particular sensation being inside. The suit itself, as I mentioned before, has a portable, let's say, life support system with different sensors that monitors the environment inside the suit and the health of the crew as well. And the telemetry itself is communicated to the base station here, and the other astronauts, they are inside the station, but also to the on-site support team and the team in Innsbruck. So there are multiple eyes checking on the crew health. This is only one of the missions that the Austrian Space Forum has performed so far. We have done 12 Mars simulation. Here you can see just the latest one from 2018 in Oman, and 2015 in a glacier in Austria, 2013 in the Northern Sahara in Morocco, and then in 2012 again in Austria in the Caves. So all targeting a location that could resemble, for some features, a possible location on Mars, from the ice on one of the polar caps to the desertic environment, or even the caves that could be on Mars. So as I mentioned before, we had some slight differences for this mission, which we had the on-site support team a little bit, well, not a little bit, completely divided by the crew members inside the station, in order to increase the fidelity of what would be a possible scenario on Mars, where the astronauts would be completely isolated for any contact, personal contact outside themselves. And the experiment, as I mentioned before, they focus on multiple scientific aspects, from human factors to engineering, geology, biology, telerobotics. So it's very interesting. There are some experiments that are definitely interesting. It's worth to give a look, because okay, so there's another slide later on. I will tell you later that you can find all the information of our experiments on the website of the organization. This is what the more or less a very in a nutshell the setup that we have for the missions. So we have the habitat that is performing the different experiments, and the results and all the information, the data is communicated to the to Earth, let's say, to our mission support center, that then forward all the information, the results and data to the different scientists, so the different experiment teams. The other peculiarity that we have in the mission is that the concept, we have a delay communication. So there is no real-time communication between the habitat and the mission support centers, there's a delay. We have around 10 minutes delay, but it can be changed depending on the setup. But that's the standard. So whatever message or information or data is sent by the habitat or the mission support center to the other team, it's delayed in 10 minutes, creating a little bit of a challenge in the communication between the two teams, because for any issue or communication, you need to wait the answer. It's not going to be immediate, the answer from the other team. So I mentioned before, the mission support center in Innsbruck has multiple teams that support the mission itself, both in preparation but also in real time. And it goes from the one that you can see in the picture. There's the flight control team, where we have then there are other teams that helps on a daily basis, and also in preparation of the mission, from the flight planning team, the ground support, the IT, the remote site support. So it's a very complex actually set up with multiple teams interacting to each other to define the mission and prepare for it. Plus all the external international communication with other teams, like here in Israel, we have the DMARS team that are supporting us with the setup. As I said before, if you're interested in the experiment and also the outcome of it, in the OVF, in the Austria Space Forum website, you can find information for each mission in the Science Data Archive, with all the experiments that were performed and some of the data. And then you can even contact the OVF to get to know maybe the team behind the experiment, to get to know more, to get more information. And beside the whole mission itself, the Austria Space Forum, we are also ourselves researcher or professionals or even students working on a project. So the outcome of this project always very often is published in journals or magazines and conferences. So this is one of the objectives I mentioned before: research and promoting what we are studying, and also to increase the common knowledge worldwide. And the other point is also try to promote itself from a media perspective, what we are doing, but in general the concept of human exploration, what is required in order to make more awareness, a general awareness. So we try to get media involved to promote what we are doing and spread the word, and allow more communities or group of people that would like to do the same to start their own setup, let's say, their own team. Well, actually, this was it. Then I don't know how you want to do. If you want to do a question at the end, and then we'll go for Willi at the moment next. And then we do a question at the end.
Yes, I think that would be the best. And by the way, my name is Lara, and I'll be asking questions on behalf of the audience. But I think we can go on and then do the Q&A later.
Perfect. Thank you very much, and thanks. Enjoy the rest of the day.
We have one question from Stuart. Stuart is asking, do you have plans to extend the duration of the analog missions?
Sorry. Yeah, it was for some reason it was not able to mute myself. No, I mean itself, the mission is set. An extension would mean change a lot of the plan of many people, because we are all volunteers. So most of us took days off and from work or from studies and so on. It would be difficult to extend suddenly in a mission. Everything is set up from the beginning to last at the exact time. Because we have to consider a lot of logistics in terms of the shipment of the material, and also to take it back to Europe. So usually, yeah, when we finish the mission, then it starts the organization for the next one.
Thank you. And there is one question from the Altspace VR. Altspace VR, I'm handing it over to you.
Excellent. Are you able to hear us yet?
Yes, we do.
Are you? Fantastic. Thank you, Simone. I was curious, I know there's a lot of analog missions where we're testing the experience and the challenges. In your opinion, what do you imagine might be the greatest unmet need or thing that we're not yet testing with analog missions, the gap that we need to fill? What do you think is the thing we need to focus on?
Well, I'd say in terms of, there are two sides from technological point of view, and the other one is from like more human perspective. I mean, if you think about it, even if we are in an analog simulation, we are still on Earth. So if anything happens, you're still not that far from civilization. So knowing that the closest point where other people are more than 6 months away of a flight, let's say from space, that might be the tricky part of psychologically speaking. So that might be one point that is still not well understood, how we would behave in that case, or if it can be done. And the other part is technological. I mean, being even NASA or ourselves, there are some parts that you cannot emulate. Like you can try to still pressurize the suit or pressurize the habitat, but you still are not in the same environment with no oxygen, very low atmosphere, radiation risk of micrometeorites and so on. So there is a lot of also technological speaking that it might be still to be fully understood on what we are able to. In particular, having an habitat so far away, then how you handle the maintenance of the habitat, how you like the concept of taking with you enough spare components, or you try to build them there. So all these challenges are really, really interesting, and I'm still working on it as far as I know.
Fantastic, thank you.
Thanks to you.
And we got some more questions coming in from the Q&A panel. And next question is from Nicholas. Nicholas is saying, can you please describe some of the interpersonal experiments?
Interpersonal. Ooh, okay, then we have one experiment actually here that's called the Interteam, where you have a task. I haven't performed yet that experiment because it takes only few people from the on-site support team and from the habitat and from the mission support center, in which they have to perform a task almost simultaneously and then present each other the results. So I cannot answer more on what is the experiment itself asking during the questionnaire, because I haven't seen yet the questionnaire. But it's also an interesting concept, because then the two teams has to interact in some way. Considering we also are in time delay, then the outcome might be a bit different, or might be tricky to interact and to find. I think they have also to find each other's question from some like, I don't know what to call them. It's a kind of mix between a game and psychological aspect. And Interteam, then you have also teleoperated robots. So there is some control from remote, can be from the OSS team or even from the habitat itself.
Just with the Q&A session.
And sorry, then
we presented anyway.
I'm not sure if I answered the question. If it's enough, or you want more clarification.
All right, thank you. Let's see. So we have a lot more questions coming in. Next question is from Michael. They ask, how do you account for the difference in gravity between Mars and Earth? In particular, the weight of the suit.
Yeah, so that's why the suit weighs 50 kilograms, because the current spacesuit used on the International Space Station, it's around 120 kilograms as far as I remember. And considering the gravity on Mars, it's lower, then it's around more or less that weight. So we're talking about 45, 50 kilograms. So that's why it's 50, 45. So that would be, if the technology of the suit remain the same, then it would mean that whoever astronauts on Mars is wearing that kind of suit, it would wear 40, 45, 50 kilograms on himself.
Got it. Thank you. Next question is from Simon, and they say, a panel yesterday discussed promoting democracy on Mars. Can you field test do this somehow? can your field test do this somehow?
Yeah, that's a very tricky question because we have some chain of command here. So there is one in the crew, there is the team lead, the commander of the mission. Then the OSS team has the commander as well. Then in the mission support center there is the flight director, and the chain of command is more or less that the flight director has the last, let's say, is the highest authority. So technically speaking, we have not exactly democracy. Probably it's just we have a team lead that is deciding in critical situations. But I think it might be, if any scientist is interested to see how it works, it might be even an option to give like the crew members to decide themselves, like vote for themselves or elect their own commander or whatever. It might be a good idea for an experiment, actually.
Thanks. Next question is from George. They say, your suit overlaps waist and shoes. Are these airtight?
No, as I mentioned before, it's not pressurized suits. So being a volunteer organization, we try to do our best, and having a pressurized suit means it's a lot of effort from a technological perspective, and that's something that the organization itself is not able. Mainly all these space agencies or even big companies like SpaceX might be able to do it.
All right. Next question comes from Dana. They say, do you train damage control procedures for Mars or Moon?
Damage control, let's say that from first, since the station itself, sometimes it presents damages. Yes, actually it happens that we have anomalies with the equipment. Then there are procedure in place. So most of the procedure, especially for experimental equipment, they have some sort of troubleshooting activity. So you define some of common anomalies that might occur, and you put it down a procedure in order to say, okay, the astronaut has to follow this step to verify the cause of the issue and then try to solve it. But then the procedure cannot find the solution, let's say, then you put in contact with the mission support center and the specialist of that experiment, of that subsystem or equipment that you need, and trying to figure out what is the problem. Sometimes you need to repair it with they have some equipment inside from soldering or spare that can be used. But likely, I mean, being here on Earth, if some big damage, it means that the equipment cannot be used. You can still replace it later on. So yeah, it's some sort of damage control, very minimal. It's troubleshooting as much as we can with the spare or the material that we have here.
Thanks. Next question from Jorge, and I'm sorry if I'm not pronouncing your name correctly. And they say, what about a pandemic in Mars? How to manage that?
That's another very interesting question. That's one of the points also to try to figure out in terms of resources you want to bring along. You want to bring all the medical equipment. So we're talking about from medicine to equipment that can be X-ray, MRI, or whatever. Then it would be interesting to understand how to handle this. Well, most of the astronauts usually they do, well, all the astronauts they do a quarantine before going on ISS. So they try to see if they develop any sort of like, let's say, quick disease in terms that shows symptoms quite quickly. But in some cases, it might be something in the long term, and then how much you can handle it. So how much equipment you want to bring with you. That's another big question, is the health of the astronauts. So how you handle this kind of emergencies or development of disease, or it could need special equipment that you don't have on there.
Thanks for the answer. And as we're getting closer to the end of this session, I want to ask you, what is the most innovative experiment or activity you're doing? It could be your personal opinion. If you could just elaborate on what are the most exciting, the things we should be on the lookout for, or some of the things that you've already done.
Okay, something here. We are doing mainly a lot of robotics. So we have also a couple of drones actually. So a quadcopter and the flying vehicle. I don't know how to actually. I'm missing one moment the word anyway. And ground robotics. So the idea of having,
they can hear us here.
Having a lot of support from rovers and drones, because the drones are expected to explore the area where the astronauts are supposed to go, in order to be sure that you are not going in a dangerous area because of, I don't know, from a geological perspective, there are some ridges or canyons and so on that you want to avoid, or you want to explore a cave before they go there and then be sure that everything is safe. So telerobotics is I think is a very interesting concept to support future astronauts on Mars. And then also I mentioned before, also the psychological aspect I think is a very important one. So to be sure that the astronauts are able to understand the group.
Can I ask about the materials used for different types of materials that's been used for the spacesuit? What materials are used, and go into detail of maybe the materials that are used to stitch them together, and how is it made together?
Well, the suit itself has 3 different layers. I think one, I don't remember all of them. One is Panox. The other 2 I have to check. I don't have it in my mind right now. But yeah,
it's a Kevlar-like material. It's a Kevlar-like material with a special surface treating to avoid backward and forward contamination. So it has a special kind of surface feature to minimize the contamination when you are exploring. And as Simone already said, one of the special features we are doing in the training is what we call the exploration cascade. We really start with orbiter pictures, deliberately not using the best we have on Earth, but simulating what we have for Mars. Then we send a flying drone there. Then we send a helicopter drone there. Then we send a rover there. All is part of this mission at the moment. And then we narrow down the point of interest. And then when we've chosen, then we send the astronauts there. And we have also some a movie prepared so you can see some of our astronauts in action if for the end of this presentation. And this especially is an all-female EVA, which might not have happened that often in previous analog missions.
All right, thank you very much, Simone and Willibald. The time is up, but there are still.
If we could show like 30 seconds of movie as an end message, if you like.
That would be great. Absolutely.
One sec. Yeah. Just showing the video. So you see our 2 analog astronauts, Carmen and Annika, doing a night EVA. Also, you see them using a self-following robotic rover that they use also for carrying tools, samples, and things. So the human-robotic interaction is a big issue in our presentations, in our analog missions. So that's just a quick look at the end of our presentation. So you don't interact with our astronauts at the moment because they are already on time delay, but these pictures give you some idea of what they are currently doing in the Negev Desert. That would be all from our part. And as you can see, there is the Mission Support Center behind us and a lot more rooms that look like this for all the teams.
Thanks a lot. This is very exciting.